Good morning everyone. Let's see about different types of addressing mode in IPv4. Let's have a view about what is IPv4. IPv4 is an Internet Protocol version 4. Why we use IPv4? Because we used it to connect our device to the web. While connecting, the device accesses the internet. It assigns to a unique numeric IP address such as 99.48. Let's see how IPv4 provides support to three different types of addressing mode. Unicast addressing mode. In this mode, data will be sent only by one intent from the host and the destination address field. Here, in this IP address, it consists of 32-bit IP address of the destination host. Here, the client will send the data to the targeted server. Next, we will see about broadcast addressing mode. In this mode, the packets will be addressed to the host. The network segments, all the host will be addressed by the packets. The destination address field consists of a special broadcast addresses that is 255.255 etc. When the host sees the packet, it processes the packet and the client sends it to the all the servers. Here, the host processes the packets, so it is sent to all the servers, wherein unicast addressing mode, here only one destination and one host was there. Here, multiple servers are here. Third is a multicast addressing mode. In this addressing mode, it's a combination of earlier of two modes. That is, the packet sent either to the destination to a single host or all the hosts which is connected to the servers. In this packet, the destination address consists of a special start with 224.x, point x and can be sent to more than one host. Here the server sends the packets and entertained by more than one servers. Every network will have one IP address service which represents the network. The IP address serves the broadcast address will represents all hosts in the network. Thus, we have an overview about IPv4 three addressing modes. Next, we will see about link state routing techniques. There are two main classes of routing protocols. One is link state routing protocol and another one is distance vector routing protocol. Here, the packet switch networking is used for computer communication. Now, let's see about link state routing techniques. It's a technique in which each router has the knowledge of its neighborhood with every other router in the internetwork. Link state protocol is performed by every switches node in the network. The basic concept of link state routing is that every node construct of map connectivity to a network in the form of a graph or in a form of a diagram. Each node that independently calculates the next best logic path from it to every possible destination in the network. Each collection of best path will then forms each node's routing table. There are three main keys to understand better knowledge about link state routing technique. First one is knowledge about the neighborhood. Second one is flooding. Third one is information sharing. Let's have a brief knowledge about these key points. Instead of sending this routing table, the router sends the information about the neighborhood only. The router broadcasts its identity and cache directly attached link to other routers. Next is flooding. Each router sends the information to every other router in the internet except its neighbor. This process is known as flooding. Every router that receives the packet sends the copy of all its neighbors. Each and every router receives a copy of same information. Next, information sharing. The router sends the information to every other routers only when the changes occurs in the information. Now, we will see an example for a link state routing. Here, A, B, C, D, E, F. Let's consider this as a nodes. First, we will create a link state table from A. Number of sequence, time to line. From A, which one is the neighborhood node? It's B and F. What is the length from A to B and A to F? It's mentioned in the first table. B is 6, F is 3. Next for B. For B, which will be the neighborhood nodes C, A and F? What is the distance from B to C, B to F and B to A? A 6, C 7, F 2 is mentioned for this table. Next, for C. For C, let's view which is the neighborhood node D, E, B. What is the distance between C to D, C to E and C to F? B7, E1, D8 is mentioned for C in this table. Next for D. For D, we have a neighborhood node as E and C. What is the distance between D to E and D to C? C8, E4 is mentioned for this table D4. Then for E, we will view the neighborhood node D, C, F. What is the length between E to D, E to C, E to F is mentioned here C1, D4, F9. Next for F, we will see which is the neighborhood nodes F, E, F, A. Here, what is the distance between F to E? F to A is mentioned in this table E9, B2, A3. Step 2. Let's now create an original routing table. Here, for this original routing table, we'll consider three columns, that is destination, distance. HOP means from the source to the destination. Let's see an original routing table for A. Let's have a destination from as A, B, C, D, E, F considered here. Let's have the distance for A. For A to A, the distance is 0. That's the destination is A and HOP is A. Then for A, we have the destination B. Here, B can be reached in two ways. That is from A to B, A to F. Here the main point is need to reach B from A. Here we should see which distance covers the minimum distance. From A to B, the distance is 6. From A to B through F, the distance is 5. So let us consider the distance which have minimum, that's 3 plus 2, 5, which covers the distance less than 6. So we will choose the path from F. Now the table is here. For A, the destination B is 5, covers the distance 5 from F. Now let's see for C. Destination C. For A, to reach C, there are 3 ways. From A to B, then C, then A to F, E, and then C, then A to F, B, C. Now we should see which path covers the minimum distance. So the minimum distance covered by C is 12 through F. Next for D, the minimum distance covered is 6 through F from A to D. Then from A to E, the minimum distance is 12, which has passed through F. Then for F, the minimum distance for A is 3 to F. Next, the same is for B. From B, the destination is A. The distance covered is 5 through the neighborhood node F. Next, for B to B, the neighborhood will be B. So, distance covered will be 0. For B to C, the distance covered is 7 from the neighborhood node C. For B to D, the minimum distance covered is 15 through the neighborhood node F. Then from B to E, the distance is 8 through the neighborhood node C. Next for B to E, the distance is 2 through the neighborhood node F. Then the same condition is for C. For C to destination A, the minimum distance covered is 12. The neighborhood node is B. Next for C to B, the distance is 7. Then HOP, that is the neighborhood node is B. Then for C to C, there will be no distance. So the neighborhood will also be C. Then C to D, the distance is F and the neighborhood node is E. Then C to E, the minimum distance is 1 with the neighborhood node E. Then from C to F, the minimum distance is 9 with the neighborhood node B. Next, the next table is for D. From D to A, the minimum distance is 16 through E. From D to B, the minimum distance is 12 through E. Next, the destination for D to C, the minimum distance is 5 through node E. D to D, there will be no distance, so it's 0 and the neighborhood is D. From D to E, the minimum distance is 4 through E. Then D to F, the minimum distance is E through F. Next, for E. For E to A, the minimum distance covered is 12 through the neighborhood node F. E to B, the distance covered is 8 through the neighborhood C. From E to C, the distance is 1 through the neighborhood C. E to D, the distance covered is 4 through the neighborhood node E. E to E, the distance is 0 through E. E to F, the distance is 9, neighborhood is F. The same for F. From F to A, minimum distance covered is 3 through A. F to B, distance is 2, neighborhood B. F to C, distance is 9, HOP is B. F to D, distance is 13 and F is E. F to E, the distance is 9, HOP is E. F to F, 0 through F. That's all. Thank you.